Welcome. In this lecture, I want to go through an example of linear approximation where we're also going to have to determine whether it's giving an overestimation or an underestimation, remembering that what linear approximation is doing is pretending that we're on the tangent line at a close by point where it's easy to compute everything. So it's a tangent line at the easy to compute point. But then we're going to use that tangent line because it's still going to be close to the graph of our function to compute our value. Okay, so we can actually look at the tangent line to understand in the picture. So to understand whether we're an over and underestimate. So here's the example. Okay, so this is what we want to do. So this has two parts. So in the first part, I want to use the linearization. So use the linearization. Use the linearization of, and then I have my function f of x equals, so if f of x equals the square root of x plus 3, and we're going to use it at a equals 1, so at a equals 1, and we want to use that to approximate. So to approximate, and then we have right, so we want to approximate the square root of, and then this is going to like our 3.98. There's something tricky in here because looking at the function here, notice that that's an x plus 3 in there. So this is actually my x plus 3. But from that, you can figure out what my x is actually. So that's going to give me that I've got my x is equal to 0.98. Okay, it gets tempting to think it's 3.98, but we need to remember what our function actually is. Okay, so now the question is this an overestimate or an underestimate? That's the second part. Okay, so is this an overestimate or an underestimate? So overestimate or underestimate. That's got to be impossible to read. It's hopeful I could get away with just sticking a letter in there, but that's not going to work. Underestimate. There. That must be much easier to read. Okay. Here we go. So let's first, in the first part, we need to find the linearization. Okay, so A, so let's do the linearization. So we recall that the linearization, we're going to get, so this is L of x, right, is going to equal, right, and I don't write approximately here because this is actually this is the linearization. This is the equation for the tangent line. So this is going to equal f of, and then this nearby value a plus f prime of, and then we have this a again, and then we've got x minus a going on. So we're going to write in here x minus a. And looking at this and knowing that we're going to need to compute everything with this a, we want a value that's close to 0.9a, which is easy to compute. So we're going to choose a equals 1. Okay, so here we're going to have, so for us, we're going to have that a equals 1, because that's a value that's close by to 0.98, that's easier to compute, and x equals 0.98. We're already told what our f of x is, so our f of x is equal to the square root of x plus 3. Which is equal to, and then we have x plus 3 to the 1/2. So x plus 3 to the 1/2. Okay, and then just taking the derivative of that, so f, and then we're going to take prime of x, so this is going to be f prime of x. This is going to equal, so we carefully use a chain rule here, and we get 1/2 x plus 3 to the minus 1/2, and then we multiply that by the derivative of x plus 3, but the derivative of x plus 3 is just 1, so we didn't actually need to multiply there. Okay, perfect. So this is what we're going to kind of plug in. So what we're going to get is going to be, this is going to be, so we first we have to compute. So we have all these things to compute, so let's worry about f of a first. So how do I compute f of a? Well, here, this is just going to equal the square root of whatever our a is plus 3, but we know that our a is equal to 1, so I can just put that in there. Okay? But this is just equal to, so what is that equal to? That's just equal to the square root of 4, which is equal to 2. Great. So now we've computed our f of a. And now we keep going. So we also need, in here, we've done our f of a, we need our f prime of a. So our f prime of a, so our f prime of a, well, now we can use this function that we have here. So this is going to equal, so I have, let's see, we have 1/2. And then we want to put our parentheses, right, where the x is there, because we're going to want to put our a into there. Okay. And we go ahead and we put our a in, which we know is 1 from up there. And then this is going to equal, let's see, we have 1/2, and this in here is 4, so I have times 1 over the square root of 4, because minus 1/2 means I'm doing a square root on the bottom, right? Okay. So this is just equal to 1/4. Great. So now we have everything to plug into L of x. So we have everything to plug into L of x. And to plug into, and we want to plug it into this kind of L of x. Okay. So we go ahead and do that. So we're going to get, if I take, right, so L of x, so using the formula here, right, I have, and maybe I can write everything that I'm going to use above. Okay, so L of x is the same thing as, so every time, so I have 0.98 here, 0.98, and then here I have 0.98, right? And I've computed f of a, I computed that here. So this 2 goes there, so this 2, right? Is going to be what goes up here, so this is going to be 2. And then I have this 1/4 here, so let's go ahead and put that 1/4 there. And then I know my a value, right? I know that my a value is 1, so I'm going to put that in. Okay, so then I can go ahead and do this. So I have L of 0.98. So L of 0.98 is going to equal, so I look up there and I've got my 2. So I have 2 plus 1/4, and then I have that 0.98 minus 1. So 0.98, and then I have like minus this 1. Okay. So I'm going to get 2 plus, and then I have 1/4 times 0.98 minus 1 is actually minus 0.02. Okay. So this is going to equal 1.995. Boom, 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 boom. Okay. Now let's look at like the picture over here. So if I have my x and I have my y, so this is for B. So that was actually my answer for A. I just plugged all those things in once I computed them. With the trickiest part just being recognizing that the inside is x plus 3. So we're actually looking for x to be 0.98, and then our A value is the close by one, which is 1. Okay. So we have the graph of our function, which looks kind of like this. So this is my y equals f of x equals the square root of x plus 3. And then I'm looking at 1. And if I was to draw the linearization there, right, what would happen? So I would get something with the same kind of slope as this graph. So I'd get something like this, and it's in, right? But remember, I'm using the linearization to compute it, and because it's above it, it's an overestimate. Okay, so we're getting an overestimate. Right, so it's an overestimate since the tangent line is above the curve. Since the tangent line is above the curve. Okay, great. So we just kind of went through another example. We've done the linearization before. As I said, the tricky part was recognizing that in this circumstance, because the inside function is x plus 3, my x is actually 0.98. My a is a value close by, which is 1. And then you do the same things with taking the derivative and everything and just plugging it into here. Then we remember that the linearization is at 1. So this is the tangent line here, and you can see it's above. So we know that the value that we got was actually an overestimate, right? So I hope that made some sense, and I will see you in the next lecture.